In this topic, we're going to be looking at finding the surface area of prisms and cylinders. Let's begin with this one. Marcy works for a toy company that sells sets of painted blocks. The company wants to find out which type costs less to paint. Which block has less surface area, because the less surface area means the less paint that they will have to use. Now, the most important thing about this section here is the lateral surface area, or the lateral area. So what that means is it's the area of all the sides of the object except for the top and the bottom, or the top and the base. So for example, the lateral surface area of this rectangular prism over here would be everything except the base and the top here. So you would find the area of those four sides. And for the triangular prism here, it would include all three sides and not the bottom and not the top. So it would include those three sides. So now let's look at this chart and let's fill this out. So for the square-based prism, or the rectangular prism, let's look at the area of the base of it. So starting off here, the base is what it's sitting on. So the base area would be 5 times 5, because these measurements are the same thing as down here, 5 and 5. So 5 times 5 is equal to 25. Now let's look at the triangular based prism, or the triangular prism. The base of it here is a triangle, and the formula for the area of a triangle is 1/2 times the base times the height. So here they laid it out for us. They have the 1/2, then the base they said is 6, which it is here. You can see that, so that would be the same as down here. And the height of the triangle is 4. So 1/2 times 6 times 4 is 12. So now comes in that lateral area word. So this is where we're going to find the area of all the sides of these prisms, not including the top and not including the bottom. So how we do that is we take the perimeter of the base, so the base perimeter, and we times it by the height of the entire object. Now remember, the perimeter is the distance around the object. Think of the perimeter highway in Winnipeg, or just outside of Winnipeg. It surrounds Winnipeg. It is the perimeter. It is going around Winnipeg. So the base perimeter of the rectangular prism is the distance around this here, this square. So if each side is 5, 5, 5, 5, and 5, we're going to multiply 5 4 times to get that perimeter. And then what we're going to do is we're going to times it by the height of the object, which is 7. So 4 times 5, that is 20. So that's the perimeter around the bottom, 5, 5, 5, and 5, or 5, 10, 15, 20. And we times it by 7, which is the height of the rectangular prism. And that gives us 140 centimeters squared for the lateral area. So let's do the exact same thing, but for the triangular prism. So the perimeter of the triangular prism base is going to be, well, this side is 5. This side is also 5, as you can see on the top here, 5 and 5. And this side over here is 6. So 5 plus 5 plus 6 is equal to 16. So we're going to have 16 centimeters, and we're going to times that by the height of the entire thing, which again is 7. So 16 times 7, which is equal to 112. So now let's calculate the total surface area of both of these objects. Starting with the rectangular prism, we're going to do 2 times the base area, because we just found the area of the base, but the top of it is also the same area. So we need to times that by 2. So we do 2 times 25. And then we're going to add the lateral area, which we had 140 for. Now, that's what we got right there. So the total surface area of this one is 190. Because 2 times 25 is 50, and 50 plus 140 is 190. So again, let's do the same thing for the triangular prism. So we're going to do 2 times the base area. So 2 times, and the base area we got was 12. So 2 times 12. And then we're going to add that lateral area that we had over here, 112. So 2 times 12, that's 24. 24, and 24 plus 112 is 136 centimeters squared. So now it's asking which block has less surface area. Well, 136 centimeters squared is less than 190 centimeters squared. Therefore, the triangular prism or the triangle-based prism, I'm going to say triangular prism, has less surface area, and therefore it'll be less expensive to paint. In the next example here, we have to work backwards a bit, and you'll see in one sec. So Karen is designing a plastic wrapper for a cylindrical roll of R12 insulation. The surface area of the wrapper is 2,375 inches squared, or square inches. So you'll see they give us the surface area here. But now it's asking, what are the width and height of the rectangular part of her design to the nearest inch? So we need to work backwards given the surface area, and we need to find the width and the height. So in order to find the width of the rectangle, we talked about this in the last topic, it is the exact same as the circumference around the circle. If you think about this net closing into a cylinder shape, this part of the rectangle would have to wrap around the circle here. So that's why it's the same size. So in order to find that, we're going to have to do the circumference formula. And the circumference formula is either pi times 2 times radius or pi times diameter. So in this case, they gave us the diameter here, 14 inches. The line is going all the way across the circle, so we know they gave us the diameter. So we're going to use this one here, pi times diameter. So to find the width of the rectangle, we're going to do pi times diameter, which is 14, and we get 43.982 inches. And I'm just going to write over here that we are finding the circumference. So the width of the rectangle is about, we'll round that to 44 inches. So now let's see how we can use this formula for surface area to get the height. Now remember, the surface area formula that we used in this chart here was finding the base and timesing it by 2. So we found the area of the base and we timesed it by 2. And then we found the lateral area and added that to it. So we're going to do the same thing here. We're going to have the area of the base, and the base this time is a circle. So the area of a circle is pi r squared. And we're going to times that by 2 because there's one on the top and one on the bottom of the cylinder. So here is that times by 2, and here is the pi times radius squared part of our equation. So our radius in this case is, well, our diameter is 14, therefore our radius is half of that, which is 7. So pi times 7 squared. And then we need to add in the lateral surface area. And our lateral surface area, if you remember from the chart up here, we found the base perimeter, and we timesed it by the height. So we just found the base perimeter. The perimeter of the base would just be the circumference of this circle. So we found that the circumference of the circle was approximately 44 inches. We'll use this decimal one. We'll use 43.982. So 43.982 inches, and we need to times that by the height of the entire object in order to get the lateral area. H means height over here. However, we don't have the height. They never gave that to us. So we need to figure out a way to isolate this H all by itself so we can get the height. So let's keep going down here. So now we have the blank over here. It says surface area of cylinder. Well, they gave us the surface area of the cylinder up here. They said it was 2,375. So we're going to plug that in, 2,375. And what we're going to do now is we're going to do this little pink part of the equation we have. We're going to do the 2 times pi times 7 squared. Now for that, I would recommend doing 2 times pi times 49 in your calculator. I like calculating the 7 squared first. So 7 squared is 49. So then 2 times pi times 49 gives you 307.876 inches squared. And we still have this 43.982 in the bracket over here because there's nothing we can do with that yet since we don't know what the height is. Now our next step is to get that h isolated all by itself. So the first thing we're going to do that is we need to get rid of this over here. We need to move it to the other side of the equation. And how we do that is we need to cancel it out by subtracting 307.876 from both sides of the equation. So we're going to subtract it from there and we're going to subtract it from here. 876. So then if we have 2,375 minus 307.876, we get 2,067.123. And all we're left with on this side now is going to be this part of the equation here, because this other part got canceled out. So these two things, they cancel each other out. It's equal to 0. So I'm just going to plug this in here. 43.982. We still haven't touched that yet. So now we need to get that h all by itself still. But it is now multiplying this number next to it. So in order to get rid of that number next to it, we need to do the opposite of multiply, which is divide. So we're going to divide both sides by 43.982. So that means here's our division line. If we write this line here, that means divide. So we're going to divide by 43.982, and the number on the top is going to be what it was in the previous step, 2067.123. So if we divide these two numbers, that is going to cancel them out. So 43.982 divided by 43.982, well, that would just be equal to 1. So they cancel each other out, and that leaves the h all by itself on that side. And then if we plug in this other side into our calculator, 2067.123 divided by 43.982, we get 46.998 inches, and that is equal to the height. So the height of the cylinder is approximately 47 inches to the nearest inch. So this question here is tricky. There's a lot of steps in working backwards, and if you need help, please let me know.